but I forgot my camera. I forgot my camera. 1 second. I just forgot I'm using my phone camera. Get my screen. My green screen. Okay. All right. Yeah, gonna be that. And yeah, it's not perfect. I don't care. Gonna be like that. I don't know why the chat is not opening. But today we're gonna learn and do some vibe code again for Elixir, right? So let's see, gonna be by sides. Let me open restring here. Oh, maybe here in another monitor, because now I have second monitor finally. Just check if everything okay. Yeah, audio is okay. And let me see. All right, so sorry. What? So let me flip that. Yeah. So now it looks like I'm looking the screen, right? So the idea today is I was checking my email in the Elixir forum. What the fuck? Let me stop that. And 1 second. Just need my chat working. Okay. So hi. Yeah, so I was checking an Elixir forum in my email and see some good news here about Elixir. For example, I'm gonna have type inference of all constructs, and I see some libraries like localize for localizations, and what I like to read with you guys is the mesh. So the mesh is something called capability-based routing for process on the beam. And so I opened that one and I starting reading here. By the way, what it is? There's no time like the present to jump into Elixir, the functional language that taking the programming world by storm. But as well as catering to the community more general needs, we have a strong focus on learning. So you have been curious about Elixir or just started join up in a great company. Nice. This was also driven by the community, etc. This not all. We have a lot of other features and some cool monthly giveaways. Wait for it. Take a sip of Elixir, sign up, join. Okay, I'm already signed up. And yeah. So let's see. Oh, no, it's not that one. Oh, that one is cool too. Talking about pipe coding. It's that one. Wait. What? No, it's not that one. That one is cool too. Is that one? So that guy, I think it's Antonio. Looks like a Brazilian guy. I don't know. He created that stuff. Yeah, Brazil. He created some good topics. Catch-all thread. And I was reading about mesh, and I cannot fully understand, but I think it's good to present to you guys the alternative we have in Elixir. So I would like to share Mesh, a new open source Elixir library developed by the Elixir community. I don't know what it is, but looks like they have something somewhere, maybe in GitHub. me take a sip. So Adriano Santos from São Paulo. And all right. Yeah, I think that's the company, and they create this Spawn. I don't know what Spawn does, but it looks like the actor mesh. Kubernetes, distributed systems. So Spawn, drive your business with stateful computing. Spawn, it's your actor native service mesh for durable stateful computing. Polyglot by design, protocol agnostic by nature. Write once, run over all protocols. Erlang native, gRPC or HTTP with an automatic transcoding. One implementation accessible everywhere. No boilerplate, no glue code, just clean actor abstractor that speak all your transport fluidly. Spawn simplify the hardest part of the distribution system, managing state and scale. By wrapping it an actor model that's native to the modern protocols and tooling, built by contributors to Cloud State, is bringing what is Cloud State? It's bringing durable computing to your favorite language: Elixir, Java, TypeScript, Python, Rust, you name it. Huh. With Spawn, you stop worrying about infrastructure. Glue will start delivering business value fast. Why you love Spawn? Durable computing via actors. Your business logic is always on, stateful, with snapshotting, passivation, and automatic recover backend. Write once, run all protocols. Huh. Polyglot by design, coding Elixir, Java code. Right. Workflows made easy. I'm thinking here, I'm using Python for CapituAI, and I started using Elixir too, and TypeScript. So I could use that stuff. Workflow made easy. Spawn makes orchestration complex business process a breeze. Compose actions using side effects, chain logic with pipes, or forward and routing requests seamless with forwards. All first class sentences in the Spawn model. Projection actors need materialized views. Spawn supports projection actors, dedicated actors that derive and maintain views until system state in real time. Perfect for read optimization, analytics, or integration with external system. Seamless scalability. Spawn model naturally scale to match your system needs. On-premise deploy massive cluster, high availability, fault tolerance can built in. All right. First class observability, simplified infrastructure. Here, one example. That's in what is that? Go language? That's not Python, right? What it is? Oh, Scala? I don't know what it is. Maybe Dart. Yeah, we have actor, option, kind, stateful, state type, snapshot, RPC sum, value payload return sum response, option. All right. Implement once access everywhere. Right, so the proto buffer. Oh, that's a proto buffer syntax? Oh yeah, that's proto. Nice. So here's define this the structure. I like it. Then can I implement in Elixir? Oh, that's why you can use any language. So dev module, Spawn SDK example, actors example, use, etc. alias. Yeah, okay, you create a module, use some stuff, some alias, and here action. So invoke with alias example sum, that's the function there. for example, actor here. So we have action with the function, receiving the context and the payload. That's type, right? Looks like type, like removing from context state as JSON data value to use state value and value, right? And here you can use the pipes from Elixir, value of state, new value, response, right? Now you can call it from multiple ways, like from Java. Okay, so here he implement how they gonna connect. Okay, in Java you have the man can have a spouse system, create something, builds. Then we have a start, should be a thread probably, or not. No, it's not a thread because we don't have a join, right? I don't know if they have a sync. Maybe it should be have a sync. Create a reference to the actor. Create an actor reference. Why Java do that? Example actor have payload set value build. Then we're gonna invoke. Yeah, and you have an optional if present something, or invoke direct with gRPC, right? Or HTTP transcoded with any client. One contract, multiple protocol, instant productivity. Good for polyglot teams. Infrastructure boring. Let's handle that. Forget about Kubernetes hell, services meshes, and complex orchestrations. Paul abstract all that. Actors get scheduled by the bean, right? State gets persisted by the bean. Protocol gets exposed automatically with just one manifest. Cage Jinsei. Opa, por que Elixir? Porque Elixir é top demais. Como nesse projeto a gente está explicando aqui que ele consegue substituir, nesse caso específico, Kubernetes. O que é muito bom. Cage, Jinsei. Cage do Naruto? Você entende inglês? Posso continuar em inglês? Se você não entender, aí você me pergunta, eu traduzo. É bom você praticar inglês. Focus on what matters. Business logic. So how Spawn empowers your team? Pode continuar. Nice. So how Spawn empowers your team? Accelerate development with consistent patterns, scale easily across cloud and on-premises, run resilient stateful apps off the box, embrace polyglot architectures. Embrace, okay, deploy with confidence, backed by robust runtime. Nice. Okay, so because of I checked the email about the library called Mesh. Mesh was created on top for Spawn to be used. And the idea today is try to understand a little more about Mesh, because understand a little more about Mesh, you're gonna understand more about Elixir. So let me get greater here. Can I put Portuguese too, side by side? Maybe. If I go like that and translate, then I can remove here. I don't remember the shortcut, but what? Wait, here, no, one side by side, yeah. Here, I think I need to translate first, right? Nunca vi alguém estudando Elixir por aqui. Achei interessante. Comecei a aprender recentemente. Legal. É raro, né? Elixir é difícil encontrar gente que programa em Elixir. Quanto mais que ensine em Elixir. Tem bastante conferências no YouTube. Eu assisti várias muito boas. So, Lab Translate para português. And then I'm trying that one. Oh, I think I need to translate here. If I can. Nice. Okay. So, okay, hello everyone. We'd like to share Mesh, a new open source Elixir library developed by, I don't know how to spell that, community. Mesh was created as part of the work on Spawn, where we needed as a reliable and scalable way to route messages to a specific group or process. So just to understand, let's call it wrong. Just to understand what they mean for process. Oh, I need to renew my stuff. I think I can use the free one. My teacher works, Cage said, my teacher works what functional programming languages. Elixir is one of them. I'm getting in a project of a research with him, and I need to have some level of knowledge. Nice. So a good website for you, it's Learn on X. Let me share in the chats. Erlang. You can put in Portuguese or English. I always like going English to learn the terms. But here, some like way to know the syntax and some especially if you forgot how to, like here it's guards, for example. So they're gonna explain and give some examples, right? So functions, etc. So very, very cool. So yes, I think I still have the actor model. So what's happening inside the bean, I'm also learning. So we're gonna just teach you what I know, what I don't know, we learn together. So we have the bean VM, and inside the bean VM, yeah, it's not pretty. Try bean VM. I forgot how to use that. Oh, now I can do that. Nice. Why they change it? Oh. Okay, maybe because I don't know. Yeah, so the way you see the Beam VM where Elixir runs, it's actor model where each we have each program. I think it's not program, to be honest. I think it's each function, maybe module. I think it's each function can be a process or is a process. I think now each function, I think it can spin up a process. And then the process can talk with others using messages like people. And each process has your own state here, immutable private states. So the BNVM already allow people create a cluster. So the cluster is gonna be like a lot of VMs, BNVMs together. One VM here, another here, another here. That can be connect. Right. Wait. Yeah, they can be all interconnected. Can be all interconnected across networks. So that can have one IP. It can be node 1. Some IP. That's other, and other. And don't matter where the function is. I think it's per program now. I think I'm remember. I think that's the nodes. Inside the nodes, we have a multiple process. That's process. And that process, for example, can send a message or receive a message from another nodes across the cluster as transparent. I built a flight reservation program that do that simulation. I think it's in the live number 1. Okay, so let's go back here to the text. No, that's not the case. That's for about researching. You said about researching. Cool stuff about AI researching, but let's go back. Close that. Yeah. So where we needed a reliable and a scalable way to route messages to specific groups of process across the clusters. Because so in Elixir you can do that automatically, kinda, right? But you cannot group process. They're gonna explain later. With the deterministic behavior and minimal coordination overhead. During spawn development, we evaluated existing solutions such as PG. I think it's process group. I don't remember. Oh, I don't think we still needed that, right? Because I want to have, let me redo that. I think I want to have Claude's. Oh, somebody said me to use Gemini to study. Let me try. They said they have a Gemini learning mode. Oh, wait. I'm gonna expose my stuff, right? Yeah, here. And yeah, so let me put that one here. And let's try learn something. By the way, most of the time I have videos on YouTube. Let's see if they're gonna help us understand that better. I'm gonna close that for now, just to make more clear. Oh, my eyes. Let me try. Oh my god, my eyes. Yeah. Let me close that one too. Here. So yeah, PG. But it's PG. I heard about Horde and Process Hub, but I don't remember what's PG. If something's native. That's an atom, right? The 2 columns, it's atom, like a constant in Elixir. But also I think it's the name of the project. Oh no, it's native process group. Native Erlang part application kernel. Yeah, nice. In the context of blog, mesh a solution default, but they don't work for them, right? Explaining the PG. So PG allow you say that process, the PID, right? Process ID. Now it's a part of the group chat room. And then other process in each node in the cluster can ask what's the PDs in the group chat and gonna receive the list of all members. What's the difference? Yeah, we have PG2 also. I saw some videos about. That's the current one. Yeah. It's scalable without locks. Globals. Introducing UTP. UTP, it's kind of, I think it's a library. Default libraries. Also the difference, they don't do routing. They just do discovery. So how works in PG? You ask to PG, give me the members of the groups. The PG returns a list. You, the developer, need to decide for what PID send the message. I see. Choose. Okay. Yeah. So makes sense. Oh, that's why they call capability based. Okay. So now I'll make a lot of sense. So the PG should be enough, but you need to define what's the node and process should be dealing with that, and they made it in such a way that's automatically. I can explain a little bit. Hard. Oh, hard. I don't know how to call that. Elixir. Yeah, it's supervisor. So hard distributed supervisor and registry backed by Postgres. So they also do distribution, like application to scale, right? Distribute your application over multiple servers with hard. It's comprised of dynamic supervisor. I think I'm using that one in my project because AI created for me, so I'm not sure, but I think I see when open Zen. Oh, it's not Zen, it's Z. A lot of Z. Let me close Zen. Z. Yeah, so that's a Capitu worker, and that's a flight reservation. So people can have, like, people can try reservation some flight, take some seat. That can be done with Elixir. So I think you need to go to the mix to see what they're using. As we have Cowboy and extra apps. Okay, let's see here in clustering. I see some cluster loads in manager nodes. Yeah, here how you can connect the nodes. We're not using dynamic supervisor. Should be the seat, right? We are using Gene server, right? And then I think Gene server inside use why it's not working. Yeah, I cannot open anymore. I don't know why. Go to definition. It's not working. But yeah, I think they use dynamic supervisor inside. Almost sure. I see here we have dynamic supervisor. I don't know if that's native or was created by AI. So why dynamic supervisor? Yeah. The regular supervisor, children define and compile time, children create a runtime. So the supervisor supervise the process. If they fail, they restart. Basically, do that. They have a children's. Start links inits start children. Start child. Here, do something. That's the case, like matching case, like Rust. So in case the return it's okay with the process, do something in returns, and that functions returns. Otherwise, if you return an error, like that is a JSON, right? That's a constants. Return a error and already started plus PID, debug, and return the same. And if you return an error, I think it's that is if you return something else, just inspect something else. It's an else case. Here's the same. Stop the seats. Yeah, dynamic supervisor. I think we created the dynamic supervisor, right? I don't know why it's not working. Seat supervisor. Managing seats. Supervisor dynamic for process management. I think it's built-in, right? I think it's a native. Okay. Yeah. Let's go back here. By the way, that should be in number 2. And that's also number 2. Right. So hard, they use dynamic supervisor in the distributed register. Hard, it's built on top of Delta CRDT. I worked with CRDT before. It's a beautiful stuff for synchronized data. Better than OT. And it's cool to see something called Data CRT here for build distributed application Elixir. Very nice. So CRDT means, if I'm not mistaken, conflict-free resolution data types. They can resolve synchronization between datas without conflict automatically, even if people it's offline. Very nice. It's better than OT. OT is that where I think it's OT means something transformation, where it's Google used here. Efficient synchronization of state of base CRT. And Delta state replicated data types. Almeida. Oh, that's Brazilian? I don't remember that. The guy is Almeida. Brasilia. Paulo Sérgio Almeida. Ha. And Carlos Baquero. CRDT. Nice. Portugal. Oh, this Portugal. Okay. Yeah, conflict-free replicated. Okay, I missed the error. So conflict-free replicated data types. So you create data types that can works as synchronous. System model. Yeah, very nice. Yeah, I remember the counter, the states. Okay, so basically create some library that allow you sync data across a lot of nodes. Nice. You can read, you can take, you can put. So you have, for example, just to understand, so you have a CRDT1 here. That's the type. I don't remember now. They have a name and a type for that one. I think it's a list. I think a list right first something. I don't remember. And one kind of types. Or a map, I don't know. Here, make they aware each other. So we have the two be in sync. So you can read, it's empty. You can put two values here in the key value. Then you can read the second one, and the second one is gonna already be sync. Gonna already have the information you put in the number one. So you can get only one part, and you can get only one part. Use atoms carefully. Any atom contain a key and value to be replicated across all nodes and will never be garbage collected by the bin. Okay, nice. So he talking about using atom inside here, probably. Nice. So Horde it's based on that, and yeah, since Horde is built on CRDT, it's eventually as opposed to immediately consistent, although it does sync state with its neighbor rather aggressively. Cluster membership in Horde is fully dynamic. Nodes can be added and removed anytime, and Horde continues to operate as expected. Dynamic supervisor also use a hash ring to limit any possible race conditions to times when cluster membership is 10. So that's something I want to understand about the hash ring later on. Explain a little more about hash ring. And let's go back here for the mesh. So they have also process hub. So process hub Elixir. Oh, also the in the forum. Nice. And here in the X. So the X docs is the documentation. Sorry. Let me take some tea. Okay, dry inspiration. So I don't know, he's the guy. Anwar Al-Fatahi, I think. It's Estonian. Spain. Nice. Estonian. And nice, cool. So he likes some Haskell, Rust, Ruby, and other stuff. And Process Hub is a library designed to manage process distribution within the Elixir cluster. Each cluster initiates its own hub under the supervision tree, and all these hubs collectively form a cluster. Huh. Why hub? Draw inspiration from frameworks like Horde and Swarm. So Swarm is something else. One of the primary motivation behind developing this library was the necessity to replicate process in order to enhance reliability. I see. The library was originally a component, another project that was tightly integrated with it until it grew and made the decision to open source and extract it from the code base. Please be cautious with using libraries currently in alpha release. That's 2 years ago. Key feature: cluster distribution. Process Hub allow you effortlessly distribute process. So normally when in the forum has something like that, I go to the YouTube because probably they have some Elixir conf about that. Elixir conf. Whisper. Tiger Beetle X. Oh, Tiger Beetle with the Zig. Zig love it. Zig is a beautiful language too. It's not functional. It's like kind of Rust, but more beautiful than the Rust. And they create a Tiger Beetle database for payment transactions. So I think I need to list in that one later one. Okay. Yeah. I don't see Process Hub conference. That one is very good too for distributed Elixir. Oh, my ears. Oh, 7 days. Oh, that's recent. Very recent. Yeah, so Tiger Beetle, distributed financial accounting database designed to mission critical safety and performance. 1000 faster than general database. And here they show how you use it in your Elixir application with the Tiger Beat and Elixir client built on top and official Zig client. Beautiful, that beautiful, beautiful. After exploring the library, you dive in, you learn about the understand the niche research and discover how not blocking API pairs perfect with the Elixir messaging passing. We will also cover some trade-off in the design of the library, macros versus code generation, efficient mutability. That's something I still don't know about Elixir. I still need to learn about the metaprogramming aspect. Okay, that's gonna watch later. Watch later. And let's finish here. So configurable strategies, tailor your distribution strategy to specific needs. For example, offer a range of strategies for redundancy handling, process replication, network failure, mitigation, and more. Scalability and availability, designing with scalability availability in mind. Process hub operations are predominantly asynchronous and not blocking. It's eventually consistent. Nice. Decentralized architecture and react to events. Ships with a set of events that can be hooked inside the trigger code. Cool. Very cool. So here the last message is just to understand. New release, bugs fixes. They said to not use in production, right? Still beta. It was alpha, now it's beta. Start results, stop results. Okay. Nice. Let's go back to our. So during spot development, we evaluate existing solution as PG, Word, and Process Hub. These are solid libraries and work very well for many use cases. However, for our specific requirements, especially around capability-based routing, deterministic ownership, and very large-scale clustering, none of them fit exactly what we need. Rather than forcing a model that didn't align with our constraints, we decided to design a small, focused abstraction that could serve as a foundation for SPAL and similar systems. That abstraction became Mesh. What is Mesh is? Mesh is a library for managing virtual process and routing messages to them based on capabilities rather than direct PIDs or global names. And a high-level mesh provides process register themselves with one or more capabilities, and callers route messages by capability and key. Mesh handle shard. That's something I don't understand, but okay. Mesh handles shard ownership and node selection, allowing system to scale without relying on global process registers. Okay. Example usage. Registering a process with capabilities. So they have an example here. Mesh registered capabilities, game and chat. Route a message into the virtual process by capability and key. So here you're gonna do a call. So that's where you normally talk with the other process, no matter where it is. So they build on top of that. calling mesh.call, they send like a JSON here. It is a object request where they define the module they created, the ID, the module here, I think it's like class. Here they have the ID, they have a payload asking to move and save to capability game. Then we have response, okay, PID, etc. Mesh also exposes simple functions for understanding cluster state. So you can also ask for what's the nodes that have game capability. They're gonna return node 1 and the IP, node 2 and the IP. Mesh all capabilities. This helper return a list of nodes that support a given capability or all capabilities registered in the cluster. Under the hood, Mesh computes a shard from the routing key. A sharding for the routing key determines the owner node for that shard and capability and deliver the message to the appropriate process, locally or remotely, without the caller needing to know where that process lives. How that's different from Process Hub or PG. This makes Mesh particularly useful for systems that need project status. Mesh is a new, okay, wait, that need what? I think we missed something from the original message. Oh, that's so more beautiful to read. Okay, so this makes Mesh particularly useful for systems that need logical actors, deterministic placement, clear separation between routing logic and business logic. Okay, it's new under active development. The API, it's intentionally small. We expect to evolve as continue integrating its small and gather feedback from real-world usage. Okay, so let's open the GitHub. They have some logo already. Elixir Erlang image file. Capability-based distributed process managing of what is mesh, deterministic placement. Same ID, always routes to same node. Deterministic placement, same ID. What is the ID? That ID? It's not ID, right? Always route to the same node. Node, no process, right? Lazy activation, process created on first invocation. Zero coordination. No distributed locks or consensus. Really? High throughput, 60,000 process creations per seconds. And 30,000 requests per second. Plus, right? Library design, you control your supervision tree. Use cases, game servers with regional routing, multi-tenant system with workload isolation, microservice pattern where different node types handle different request types. Okay, I think I understand a little bit about the sharding, what they said, but still not too much clear how and why. So capabilities. Capabilities are labels that define what types of process a node can handle. Think of them as tags that describe a node responsibility in your cluster. For example, Game. This node handle game-related process. Chat. This node handles chat message process. E-payment, of course, payments. Nodes register for the CapituAI support and mesh automatically route process requests to nodes with matching capability. This enable workload isolation and specialty and specialized nodes types. Oh, now makes sense, I think, because let's say I have a node here and for some reason that node has, it's a header, right? They have GPU. Or they need to have like more memory. And now I want to group all nodes that they have the same capabilities, because that node has some capabilities that others node don't have. So for example, they said game server regional, region, right? Regions, where we have 2 nodes in Brazil and 2 nodes in US. And if it's in Brazil, you want to route all requests for Brazil because the ping gonna be lower there. I like that. Very, very cool. Very, very nice stuff. Yeah, for example, you can have multiple kind of stuff here. For example, we can have here Brazil cap Brazil cap, yeah, capabilities Brazil. Why I'm not, take a double click for, yeah, here. Yeah, so that's capability Brazil, and that one it's capabilities GPU, for example. Right, and here we can have another one, but that's in USA, right? So let's say that nodes has GPUs, and maybe that's good to process some algorithm, or even LLMs, so something else for some reason. And also you can tag that one is from the US, that one is from Brazil, and maybe some process I don't care if that's gonna be using GPU or not. I want to just always talk to Brazil nodes. Yeah, others maybe I want to talk with all GPUs, no matter if it's in USA or not. So you can create a lot of kind of groups in that clusters. Very nice, right? Very, very nice. Okay, let's continue. I think it's finished. Yeah, this explanation. So some guys answer here saying that it's not a consistent hashing. So they check the codes, the source code. In the source code to create the index, it's using, oh, that's why they call sharding, right? They call that's kind of sharding, just because you're sharding the nodes. So we have the cluster, but we have the each label or kinda make a sharding. It's not a sharding, I think, but maybe it's in the concept. By the way, this is not a consistent hashing. It's just a regular hashing sharding. That is not a ring. Did you catastrophically reshard if a node is added? Okay, I think what he said means when you create a sharding here, they have ID, the IDX hash, and the hash is based on the nodes. So if I add a new node, they're gonna change the hash and stop receiving. But then he said, yeah, you should use rendev's rules hash anyway. That is, if you need to worry about resharing at all. I'm not sure. So I follow some of the discussion, but I didn't understand. So now I need to understand that. I want to understand it. So let's try to understand it. So first, what is ren? Looks like a function or some native model stuff. I think we can ask for Copilot here. What the fuck is ren? Shard filter. Capability node for capability nodes and non-shard nodes. If node is empty, return out otherwise. Take shard in length on nodes. So numbers of nodes inside the shard to create and return nodes in the index. I think it's index, right? No. Ren is an Elixir integer reminder. Yeah, I was thinking about that reminder function. You divide and returns. Here they said that the function ren came from kernel and accepts 2 arguments. It returns the reminder of the integers divisions. So for example, A lets B divide by divide. Wait, what? Why it's so complicated? Oh yeah, right. Yeah, it's right. Yeah, you divide and then multiply the difference. So example, 7 for 3, it's 2, but remind 1. And here, that's 1, and here 1. Let's see. Let's confirm that one. That should be A. That should be 7, 3, 4. Wait, 4 plus what? 2, 8. But that don't make any sense. Both arguments must be integers, otherwise raise an error. If you need a non-negative module, common for indexings, use integer model instead. Yeah. Also make sure that length is greater than 0 to avoid division by 0 error. Copilot chat assistance. Okay, so they take shards. What is shards here? What is shard here? Explain better that. Good catch. You're right about the terminology. Mesh currently uses deterministic hash based sharding, not a classical consistent hash with a ring. So what I need to understand, what the fuck is ring? We're gonna understand with it here, okay? Shard is data number bucket ID for an actor. If the result of hashing the actor ID into a fixed number, the shard and is used to pick which node do you own that actor. Detail shard for actor ID use p hash 2, which returns an integer in 0 shard count less 1. So the shard is now negative integer bucket for the actor ID, and the owner node that function we are seeing shard and capability. Get the list of nodes that advertise the capability. Shorted list to make the node ordering deterministic. Then compute index reminder and returns. Okay, yeah, makes sense, I think. So shard determines which node owns a given shard. They're gonna return the node index. So have a lot of nodes and you save the index, and the index change based on how many nodes I have in the cluster for that specific capability, right? And that should be in order. So we have, like, let's say 5 nodes. 1, 2, 3, 4, 5. I don't know what is shard. It is should be a number. ID. Let's say it's 1. Oh, I see now. Yeah, let's say that's 10, just to make easy. Shard is 10. It's just a hash number. It's not counting something. 10, wait, 1 second. Sorry. So 10 divided by, I said 5, should be 0, right? It's gonna be 1 remaining 0. So the first node is the owner of the shard 10. Let's say the shard is 11. So if that's 11, that should be 10 remainder 5, right? Because if it's 10, it's gonna be 0. If that's 11, it's gonna be 1. So the second node, it's the owner. And if that's 0, 1, 2, 3, 4, 5. So they're gonna always give. So you can have, like, you can have the 5 ID and the 0 gonna be the owner. You can have the 10 also gonna be, the 15 also gonna be. So it's just a way to make all nodes be owner of some shard. I see. Makes sense. Makes sense. Cool. So for example, if you have one shard, but wait, shard is not capability, right? Yeah, shard is not capability, because capability gonna extract some nodes, different nodes. So what is shard? Yeah, so capabilities, it's the group, right? Group of nodes. And the owner gonna be defined by that simple math. And the problem is, if I have multiple capabilities con different shards, yeah, that's complex. But I think I understand. Now it's a little more clear. Not sure exactly what is shard. What exactly is shard? What exactly is shard in that contest? context. Here's it explain about the ring. So this is a simple model-based mapping, yeah. Not a true consistent hash ring. When nodes join and leave, many shards will move to different nodes. Many shards. If you need a minimal remapping and topology changes, consider consistent hashing or Rendev's Vols hashing approach, hash ring or similar. Okay. Yeah. It's exactly what the other guy says. But I want to understand shards here in that context. I think shards something it's a part of mesh, right? Let's see. So in that file, shard is a numeric partition, a bucket for an actor ID. The integer produced by hashing an actor ID in a fixed numbers of shards. They could use that shard number to pick which node you on the actor. Okay, I think. So shard for computes the shard number for a given actor ID. So if you have actor ID, they're gonna create a hash, and they're gonna use the hash here as shard. But who is actor ID? With actors to nodes, with a consistent hash. Yeah, it's not ring, right? Details from the file. Shard for call, etc. that return a non-negative integer 0. Shard count less 1. Okay, the shard count less 1. P hash. So at S hard, it's simply the integer. Somebody call me. You can hear? Let me close the door. Where we are. So owner nodes, shard capabilities first collect nodes that are diverse the giving. Okay, shard partition the actor key space. All actor IDs that hash the same shard number will be routed to the same node. So shards partition the actor key space. All actor IDs that hash to the same shard number. How they gonna hash for the same? What the fuck is p hash does? It's a simple model-based mapping. Shard node via shard code number deterministic. It's a deterministic but not a full consistent hash ring. When the node list changes, nodes join or leave. Many shards node assignment will change. Yeah, exactly. P hash returns a non-negative integer. So we have like a normal model in this usage. If you prefer a clear intent, shard count, actor ID. What is actor ID in that context? Given ID. I think the ID is the process. I think the ID is the process. Searching the code base. Okay, they're gonna try and understand the code base. The actor ID is the stable, unique string identifier for a logical actor. Logical. That's why they said they're gonna do the separation from logical actors and business. In an entity, a process you want to route message to, it's not a PID or node name. It's the key that hashes to decide which shard and therefore which node owns that actor. Okay, so the actor, it's not the capability. Wow. Huh. So details, they have type shape. The functions expect string t, example in the code, player 123. Okay, so the actor is the user. What it represents. Any identifier you choose that uniquely identified an actor instance. User ID, player ID, order ID, room 42. All calls for the same logical actor must use this exact same actor ID string so routing stays consistent. How it's used. So you call shard, you discover the shard to produce a shard number. That shard is then mapped to the node owner to route invocation. Requirements and best practice. Keep the ID stable and deterministic for the same actor. Use a consistent format if you have multiple actor types. Don't include node or process specific on the PID, the firmware token in the ID. It should be a string. Okay, give me an example. Give me an example how to use. Okay, let's go back to the discussion. So what I said is mesh currently use deterministic hash based sharding, not a classical consistent hash with a ring. Shards are fixed and process or mapped to shard via p hash. Yeah, so the actor ID is basically the process. That said, that the deliberate design shows align with our use case. Mesh routes message to a virtual process, not persistent data partitions. Actors are ephemeral, lazily created, and can be safely recreated elsewhere. As a result, minimizing resharding costs. Minimizing resharding costs is not a primary concern for us. What is the sound? You can hear the. No, you cannot hear the dogs, right? Nodes joining or leaving do not change shard assignment. Only shard ownership. Yeah. There is no data migration involved, and no state is coupled to shard placement. Rendezvous hashing is a great tool and could be explored in the future, but for now, the current approach gives us a simpler reasoning. Big notation. O1 routing decisions and predictable behavior, which fits well with mesh and spal actor model. Still, thanks for the pointing out. We should probably avoid calling it consistent hashing in the docs and be more precise about the terminology. We always open to involve routines, etc. The guy answered, did you just AI generate the answer? It's not predictable and it's not consistent. If you had shard, I think he means shard, 2 in nodes where or node 0, 2, and 3, you get 3 return. Yeah. But then a node 1 joins and set the same capability and you get node 2 return, which is kind of the opposite of the consistent and predictable. Yeah, they make sense, right? So you have 0, 1, 2, 3. The 2 means you're gonna let the 0, 0, 1, 2 node be the owner, but because you add the number 2 and because you're always short in the list, you change the position. The answer about the AI, no, I was just trying to be polite. As I said before, perhaps the text implied that partitions should be stateful or stable, but it's not the key use case. The state of the process is not coupled to the shard. It only serves as a routing mechanism. Obviously, this don't work for all use cases. You don't need to consensus on the shard. Sorry if it was not academic or precise enough in the text. We can improve. By the way, considering the version 0.11 contribution are welcome, and I'm sure that if that use case or if a bug appears, it will be well received. All right, just etc. If talking about Claude. If you don't need to be consistent, why do you even shard in the first place? Pick random, round robin with counters. It will be much faster than hash computation and more important, will not give a falsified consistent routing. Good point. Understand? Although that was not the case, I really learned about this term. No, it's a simple. It seems you assume that is they're not strong, consistent, then sharding does not make sense. But that's not the case. Sharding is not just for consistency. Predictability, local determinism, stability, and other things probably. I didn't want to share state or inconsistent decisions from each node. If the cluster is stable, you would lose local determinism otherwise. But all nodes arrive in the same decision in this case, stable cluster with shards. Eu vejo vagalume. Vagalume. Oh, that vagalume. I don't know how to spell vagalume in English. Vagalume com olhos verdes. Regarding performance, I'm very happy with the benchmark we have done. We work more on the overtime. Of course, we can consider consistent and strong hashing as I assume, but for this version, it's okay with that. Olive Matt, buenas. How's going the blockchain series of lives? Lucas. This is brilliant concept, which remind me Kubernetes. Having it in Elixir, it's tight. In that regard, is there a possibility to provide a negative capability taint? Elixir is the language of the year. I think so. I think it's Elixir. It's underrated. And now we are studying something called mesh that creates some actor model. I don't know if that's like Scala. No, it's not Scala. It's like Akka, right? The system as the mesh, or is there an orchestration node? And when a node is killed or the process restarts the nodes. I don't think the term capability base means what do you think it means. A capability, it's a inforgable token of authority. I don't see such thing in mesh. These atoms that you call capabilities are more like roles of groups or identifier. Yeah, I agree. Because capabilities make more like I draw here. Lucas said, I did 11 lectures about 11 different blockchains. Nice. How much more to come? It's gonna be third blockchains, 30. Oh my God, today I teach about Scala actor model blockchain. Nice. What's the blockchain? Let me see. That one, right? Oh, Hathor. Nice. Hathor is Brazilian blockchain. Cool one. Very cool one. They use DAG, DAGs, right? Very nice. Very nice. And right. So it seems more like a node affinity than a timed. I don't know what is timed. Node affinity I know for load balancers, right? But timed? Loon's Scala actor. Loon's blockchain. Hathor is a Python. Still Python? Still Python? I think it's not Python anymore, right? I think it's Rust or Go. Ah, Loon is here. Oh, makes sense. Yeah. Loons. Okay, Loons I don't know. Token Drive platform. Huh. Huh. Yeah, Python. Hathor is Python UTXO that. They still in Python? Hmm. They should be having take some Rust Go or whatever. Yeah. Kind of strange using Python for blockchain. Very strange. Because it's an interpreter language. I work on Linux. You're working on Linux? When there is a new call, they ask, and when a node is killed, the process restart and the process restart at another nodes. When there a new call, the process, yes, nice. Yes, they are tags, labels, whatever you want to call them. And they serve more as a group affinity for nodes in the sense that you are addressing a process to a node only if it's a part of a specific group. Addressing a process. Okay. Lunes, it's Waves fork. I don't know Waves forks. It's Scala blockchain. Do you think handle will be meaningfully faster than hashing? I kind of doubt it make a substantial difference. Either way, the correct approach, in my opinion, will be the load balance with the two random choice streak, because randomness alone will randomly overload the handle nodes. Makes sense. That should be a cool algorithm for load balance that I don't know. The power of the two random choice, using less information to make better decisions. Oh, that's a good phrase. Okay, so let's go directly for a random pick. So mean query time and cache load refresh interval. So I think it's less. No, I think it's here's best. Cache load refresh interval. Cache load refresh interval. Why it's oh no, that's too I can understand that. That's the mean query time. Why that's 60. Best of 3, best of 2, random pick. Random pick is the equal. Huh. Waves blockchain. I don't know waves too. Okay, let me see. To see how that works. Wait. I should be reading everything. In many large-scale web servers, multiple layers of stateless and stateful service are supported by load balancers. Yes, load balancers can be done with a dedicated hardware, with dedicated software load balancer using DNS strictly or through a load balance mechanism in the client. In large systems, the resource and constraint in each layer can vary widely. Some layers are stateless; they don't have state, and They have state, but the state don't can be it's ephemeral and easily scale horizontally to many machines. Others layers may be more constrained, either due to the need to access state or contention for some other shared resource. Centralized load balancing solutions can distribute load over a fleet of machines very well. They track the amount that the load they are sending to each machine. Oh, I need to go. I need to go to hospital. Usually based on simple measuring like connection count. I have 30 minutes to go there. So I have more 5 minutes here. Because they are centralized, load balancers typically don't need to worry about load sent from other sources. They have complete control of the distribution on load. Despite this advantage, dedicated loads are often undesirable. Of course, they add cost, latency, complexity, and may introduce a single point of failure. Exactly. Cloudflare is there. Handing the task of load balancing to each upstream client is also possible, but introduce the challenge of fairly balancing the load from multiple places. That's cool. So I put the load balance on the client. So the client decide where to go. But for that, you need an algorithm. In large systems with large numbers of clients and fairly homogeneous call, a purely random system like DNS, round robin, can work very well. In smaller systems where each downstream service can only handle a small number of concurrent requests, and systems where requests are heterogeneous, it's often desirable to load balance better than random. Perfect distribution load balance could be done, at least in a rep case, by distribution information about system load across all the clients. Yeah, by distributing information about system load across all clients. The overhead of constantly sharing the exact load information between different sources can be high. So it's tempting to have each source work off a cached copy. This data can periodically be refreshed from downstream or for other clients. It turns out that's not a great idea. That should not be. The power of the two-handle choice, a survey of techniques and results for that guy. They did a survey, some research, very relevant to the problem. Okay, that should be very, very cool stuff to learn. Very, 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 but it's not today because I still need to finish that one. So the guy is talking here some stuff. Yeah. So let's finish. Try to understand what they mean for the shard. They had some review here. This is a poor library with a lot of bugs. Misleading documentation, poor applicability. Damn. This essentially does two things. You can set some capabilities for the nodes, right? You can perform some requests on the group. It will pick a node from the group, spawn some or use the existing CGN server, right? And do the gen server call with a specific payload. Each node in the group is going to maintain a share count of process per each capability call actors. In terms of library, but I call them just shared here. And this request is routed to one of these shards. That means if the node has two capabilities, a max shard count stands, so it's gonna be maintained 20 process, all that are lazily initialized. Problems. Setting capabilities, picking a node, and other problems. Nice. Conclusion. Unclear use case, bad implementation, misleading documentation. Damn. Same functionality, but without a lot of bugs, can be achieved using another process group isolation solution building called Global Group MPG and third-party Word Swarm Process Hub. But given that shard process or expect to be stateless and routing to be inconsistent, it's boiled down to just two lines. Wrote on this list and call. Yeah, that was stuff. That was Yeah, I also don't understand like why they cannot use that stuff. They have a I just reread my post and sound a bit toxic. Yes, they're gonna have a clear personal recommendation would be learn more about distributed systems, take a look at existing implementations, hoard the library, solve the similar problem, but is eventually consistent CRDT, Merkle tree structure to eventually maintain the same version of the information about which process belong to what groups. Other good example is Process Hub, which is a fake, still in active development phase. Learning more about consistent hash algorithms and their applicability. These algorithms are very interesting because they are exact mix of finite field algebra and some empirical observation how distributed systems change their membership. Don't be afraid to ask questions. Oh, I like it. Okay. Oh man, that's was harder said. They have a good feedbacks. Uh, okay. Of course. And sidecar. Sidecar. Kubernetes sidecar container explain. I think it's normally to be formula to post I don't mean the background. A sidecar. It's a container that run alongside another container with a pod. So the container run the example internet. Okay. 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 Yeah. So let's finish the live today. It's 1 hour and 30 minutes live, and I'm gonna finish studying that algorithm. That should be very cool. And yeah. So the sharding name there was not my problem. It's the naming he said. He chose. It's very confusing indeed. Very confusing indeed. But okay, I think they're gonna explain that here. Anyways, thanks for Lucas and other guys like who was here was Cage Jinsei in the Twitch. Thank you for watching and follow Lucas. I'm gonna keeping doing blockchain stuff there, and we see probably I don't know Wednesday 21 I think. See ya. Thank you. Let's finish with some cool emoji here.